For most of us in the UK, our essential resources are available on demand. But one easily taken for granted is mains water. In the Midlands and mid-Wales, Severn Trent is responsible for supply, piping water to 4.2 million homes and businesses, many of these in our second biggest city, Birmingham. But over the years, as populations grew, so did demand, a problem the Victorians faced more than a century ago. Their solution was the Elan Valley Aqueduct, bringing fresh water 73 miles from Wales.
It's Victorian engineering. It's solid, as opposed to today where everything tends to be a lot more slender and economical.
It's over 100 years old. It's a fantastic piece of engineering. It's impressive, isn't it?
But maintaining this old structure is an increasing challenge, because this is the main water supply to Birmingham, and it can only be turned off for a few days at a time.
It wasn't designed with long-term maintenance in mind, and so should we actually encounter a problem, we would only have the short periods to actually carry out any repairs.
So how does one of Britain's biggest water companies maintain a century-old aqueduct and guarantee fresh, reliable drinking water in constant demand? In 1893, work began on the Elan Valley dams and aqueduct. It took more than 50,000 men over a decade to construct. The Industrial Revolution had caused Birmingham's population to explode, and with it came disease. Clean water was desperately needed. Alan Payne is Severn Trent's lead engineer. His team have studied the system for years.
The water here lands on the mountains. It's captured in the reservoirs that were built by the Victorians some 100 years ago. And from here it is abstracted out of the reservoirs by the Full Tower, which you can see behind me. And from there it is transported to our customers in Birmingham and the Midlands.
Every day, 320 million litres makes its way down the aqueduct, a 36-hour journey to Birmingham.
The system that's been designed here operates only on gravity, which means it's a very low-carbon, environmentally friendly source of water. Often today we would have to use pumping to abstract and transfer large quantities of water around, which is very expensive and uses a lot of electricity.
The aqueduct runs downhill through tunnels, siphons and bridge crossings, winding its way through 2 countries and 5 counties. Its robust structure has withstood a century of constant use. But despite this resilience, a yearly inspection is needed, and shutting it down for access is a major job.
So any sort of defects that we notice are recorded. That builds up a much bigger picture of how significant the problems are.
Just outside Birmingham, Alan and a team of engineers are reviewing a section of the tunnel for wear and tear.
As you can see, generally it's in pretty good condition. But we're looking at this joint here, and you can see there's some seepage just coming in through the joint between the concrete, which is this part, and the brickwork on top of there. So what we would do here is actually record this, make a note of it, monitor it for next year, and then so we can actually see whether it's progressing and deteriorating going forward. But this is probably relatively minor, so we wouldn't actually do anything about this at this point in time.
When the water reaches Birmingham, it flows into Frankley Reservoir, a giant holding tank. But with the aqueduct turned off, it's just a matter of days before the city runs out of water.
We shut the aqueduct down for up to 5 days. You've got to bear in mind it takes a day for the aqueduct to actually drain down before we can get in. That allows us about 3 days to actually work inside the aqueduct, and then we recharge it with water. It wasn't designed with long-term maintenance in mind, and so should we actually encounter a problem, we would only have the short periods to actually carry out any repairs.
Birmingham sits on a number of underground reservoirs, and investigations in recent years show water levels have actually risen. New boreholes are being drilled, but even these will only meet around 2% of total demand. With such a finely balanced system, Severn Trent has been planning for a major new investment.
As the Chief Executive of Severn Trent, I believe it's my responsibility to ensure that we're investing in the right assets for the many decades and generations to come. And to be in a situation whereby there isn't really a backup supply that is as efficient as it would need to be, it would cause genuine pain to the businesses and the people of Birmingham should the aqueduct no longer be functioning for a period of time. Having analysed climate change, asset state, and also population growth, we believe right now is the optimal moment in time to make the investment for the people served by ourselves.
To allow the aqueduct to be shut down for long-term repairs, a second major source of water must be found. For this, Alan and his team are primarily looking to the River Severn.
River Severn's the longest river in the United Kingdom. Flows from the Cambrian Mountains up in Wales down through the Midlands and out into the Bristol Channel. There's around 8,000 megalitres a day is the average flow down the River Severn during the winter period.
To provide a second source for Birmingham, Severn Trent need to abstract less than 5% of the average daily river flow. Half of this can already be taken from the river near Kidderminster. But a new pumping station and pipeline is needed to transfer the rest. A further 80 megalitres will come from other sources local to Birmingham and Severn Trent's water grid. This new supply would allow the Elan Valley Aqueduct to be shut down for essential major work. Yet by arranging for this to happen only in the winter and for limited periods, the River Severn would be kept in balance. The team plans to repair and rebuild entire sections of the aqueduct, giving it life for another century. This would be Severn Trent's biggest project to date.
We're talking about many millions of pounds, many tens of millions of pounds over a number of years. That brings with it the weight of responsibility to make sure that every pound is spent wisely, at the same time as making sure we create a future engineering asset that we're proud of that serves our patch well. Of course, we want to make sure that the customer has every assurance it'll be delivered on time. We've got good conversation and dialogue with the local communities. There'll be minimal disruption to their daily lives. The funding for a project of this scale comes from the contribution of customers added to their bills. Nonetheless, we're proud of the fact that we have the lowest bills in the land. We're committed to having the lowest bills for the next 5 years. We believe this to be an essential investment for the future. This is the chance for us to invest in an asset which has served us well for the last 100 years and will now serve us well for the next 100 to come.